Biggie Boy here with a video. This is my pulse width module controller. It's a copy of Zero Fossil Fuels with my own circuit board I made up. Just wanted to point out a couple of the changes that I've made to this, or where I veered away from how Zero had his, just to see if this would help in troubleshooting. First one I'm going to show you is the capacitor I used. It's fairly large. It's a 25 volt 33,000 UF microfarad. So I think that's a bit of a deviation. I have a pair of caps here, as you can see there. It's red, green, white, which works out to, from my looking it up, is 250 picofarads. I have two of those in parallel, so that should equal 500 picofarads. The other thing I changed is I took the amperage pot off the board and mounted it up in here. I super glued it in, and that way I can adjust it through the top with the screwdriver, so it's easy access. There's my positive post there. You can see inside. There's my diode. There's the 12 volts that feeds the board. Now here's the biggest difference from Zero's and mine is I have my posts here, my negative in, my minus post in, and my minus post out. So my source and drain posts are here instead of on the side of the box. The reason why I did that is because I mounted my MOSFETs on the top with the fan. Just what I decided to do, how I did it. So I just wanted to show you, once again, just to hopefully help me troubleshoot how it's wired. It's really hard to see, but basically what I did is each FET is fed the source wire. Each one, there's three of them, and they're all identical length. So they are run off the grounded post, the incoming minus. They're all the same length, one to each one, so the resistance should be the same. And the same for off the drain. They're all three the same length, and they go to the minus outpost. So everything's the same length, and as you can see, they're very short. They're only about 2 inches long as compared to his 6-inch length. So this should allow a lot of current through. The MOSFETs I used, once again, I couldn't find the ones he suggested. These are IFRP 250s. They are rated for, I believe, 200 volts, 33 amps a piece. So this is roughly good for, 90, let's say 95 amps, somewhere around there. And that's about it. The gate wire is this black one right here. So I have one gate wire coming off the board, and it loops from each of the gates from one to the other across. This wire here, there's a pair of them, so one wire goes and does two, and that goes to the source, and then there's an extra one here, and they go to the exact same spot on the board in here. Kind of hard to hold it. I'm getting awkward. I don't know if that was a mistake using two of them, but that's, I believe, what gives it the board the feedback to let it know what the current's doing. I can't really think of anything else. Otherwise, the board is pretty much the same. I didn't deviate it with the circuit itself. It's just how I mounted the FETs. So I don't know if it has something to do with the way these FETs are wired that is creating the large voltage drop across them, that if I short across these two terminals, for example, if I'm running 35 amps through here, due to what my state of my battery charge, say I'm running 35 amps, and I've got this set at 100% duty cycle, the amperage cranked all the way up, and I'm running 35 amps, and if I short across here, it'll jump up to, say, 45. Now, if conditions are good, my battery's really well charged, the charger's hooked up and putting out, and I'm able to get, once again, same setup, 100% duty, amperage all the way up, and I'm able to get 45 amps going through here because the battery's, really putting out, and I short across, I can get up to like anywhere from 55 to 70 amps. So I need to solve this problem. Why is there such a big difference in my amperage when I'm bypassing the FETs or not? And I have proved with this add-on board that the FETs are being driven at 100% because they're according to that little add-on card, it's putting out and telling those FETs to open up at 100%, but for some reason it is limiting the current flow. So once again, I'm just wondering if it's got to do with the way I've got these FETs wired or the FETs itself. So anyways, that's it. Hopefully somebody can come up with an